Hi class, this is Professor Simcha Pollack. This happens to be the first video of the fall term, and I was asked by a student to solve a pretty typical example in Chapter 12, the non-parametric statistics chapter, in particular example 12.2, which asks you to calculate and interpret the chi-squared based on a summary of data expressed, I think, as 4 rows and 4 columns. Now, again, I showed you there are other videos how to calculate this by hand, and there are perhaps many websites where you can input the data, but I think the easiest is to use the StatCrunch that's built into the problem. So, first step is to click on the icon, and here you see the data. But there's another icon here, this little double rectangle that if you click on, and we're going to open it in StatCrunch. Okay, so here's the data, and we have to take this data. It means, for example, there are 180 people who are in that category group meeting from Generation Y. But the way the StatCrunch works, it's best to delete the totals, which are often when you do it by hand, you have to calculate by hand, so it's useful. But for the StatCrunch version, let's delete it. So we go to Edit, a column, Delete, and let's delete the total column, which is here. Say Compute, and it's gone. Let's delete the row. That's going to be row 5. You highlight it, compute, it's gone. Then you go into statistics, and here's where it takes some practice to figure out what they want. Tables. What we're doing is called a contingency table, and we already have the summary. And we know how many people are found in every category as opposed to having a data set with each person, and then you have to then put them into the category. So we have the summary already. We tell the computer what are the columns that we're going to be using, and in fact, you put the shift and you run all 4 columns. The name of the labels of the rows are found in var 1, and we do want the percent. These are some of the output, but in particular, we want the highlighted chi-square test for independence. So we say compute. And it gives us all the results. And in particular, it tells us there are 9 degrees of freedom, which is a test because it's 4 minus 1 times 4 minus 1 is 3 times 3. The chi-squared value is 64.61 when you round this to 2 places, or 608 when you round it to 3 places. And the p-value is less than 0.0001, and we'll see that in a second. So copy this. Let's go back to the question, which is, what's the chi-squared value? We say paste. And round to 6.07 is close enough because I allow an answer with even 1/10 of a point. So this will be checked. Let's check the answer. Excellent. My PhD in statistics paid off. Move on to part 2. The p-value is, we just said, 0.0001, really less than that, but it doesn't accept the less than symbol. And either way, it's very, very significant. It's much less than the 0.05 level of significance, and we're still doing a good job. Finally, the conclusion, which again, you should know from the videos, but the p-value is less than the level of significance of 0.05. 0.001 is much lower than 0.05, and therefore we reject the hypothesis and conclude that there is a significant relationship between the variables. Let's check it. Well done. And I think we're done for that demonstration of example 12.2.